Hello friends, today I am going to discuss time series forecasting. So, time series is a type of data that measures how things change over time. Because I have already discussed how to apply a data uh, through a time series. So, we did use to how to manipulate a data, how to train and test data, how to select models, how to use a matrices. So you can see my previous video. I hope you will comfortable to apply the some coding in a Pythons and to get a output. Yeah, you can forecast some time series data also. So time series data set means time column does not represent a variable, but you can say, so we try to understand means it can give so many additional informations like what are the expected if you go the in the sales industry, so what are the expected sales volume of a thousands of foods groups in a different grocery stores next quarter. Another, what are the resales value of vehicles after like automobile sectors leasing them out for 3 years. What are the passengers numbers for each major international airlines routes and for each class of passenger. And another thing, just what is the future electricity load in a energy supply chain infrastructures and others. So so look here. So now the some flavors of the machine learning for the time series forecasting. So try to understand the some important concept like a time series analysis and time series forecastings, and discovers the why the time series forecasting is fundamentals cross industry research area. Second, we have to the concentrate supervised learning for the time series forecastings. Why would you want to reframe a time series forecasting problem as a like a supervised learning problem? I have already discussed what is the supervised and non-supervised. So, and how to reshape your forecasting scenario as a supervised learning problem. As a consequence, get access to a large portfolio of linear and non-linear machine learning algorithms. And next, just Python for a time series forecasting. So you try to understand the Python library for the time series. So how the library as it look like a pandas, states model, SCIKIT, learn can help you the data handling, the time series modeling and machine learning respectively. And then experiment setups for the time series forecasting. So you can prove your advice and the setting of the Python environment for the time series forecasting. So mostly time series forecasting, the data scientist. Uh, so scientist assumptions is that there is no causality and that affect the variables. So we are trying to forecast, and they analyze the historical value of a time series data set into the order to the understand and the and predict their future value. And also to produce a time series forecasting model may involve to use a simple deterministic model like a linear extrapolations, and use the more complex deep learning approach also. And sometime we see here uh, some classical forecasting method such as exponential smoothing, autoregressive integrated moving ARIMA, you can say here ARMA, and these are the general misconceptions that the deep learning model are inefficient in a time series forecasting scenario. Many data scientists wonder whether it's really necessary to add another class of methods. So such a CNN like a convolutional neural networks and a recurrent neural network RNNs, their time series toolkits, and we try to discuss after some time. So let's see, just a time series is a chronological arrangement of a data. It is a capture of the specific columns that is often and denoted a time samples data of the simply time. So the machine learning data sets usually a list of the data point and containing important information that are treated equally from the time perspective and are used as an input to a general and output which represent our prediction. So data means just like a machine learning data. You can first column you can see the something like a sensor ID, sensor 1, sensor 2, sensor 3. Another column it represent a value, something as a integers. But time series data sets means sensor ID and time stamps. So it has mentions it may be the month, year, date, weekly date, has daily date. Okay. So let's see. Just I am collecting a data. Suppose from a stock market price. So we can collect the daily data, monthly data, weekly data. So the time frame has been given in a one column. So this type of the data is called a time series. Now other thing, just if I am going to look here, just I am going to try do something like a date indicators. Okay. Another thing, the data scientists usually leverage the time series analysis for some reason like acquire a clear insight of the underlying structure of historical time series data, increase the quality of interpretations of time series feature to a better information the problem domain, and pre-process and perform high quality feature engineering to get a richer and deeper historical data. So time series analysis is used and for many applications such as a process and quality control, utility studies and census analysis, and it is also considered the step by step and analysis of this time series. So the time series analysis the historical data just I have already discussed. So first the components of the time series: long term movement or trend, short term movement, and random or irregular fluctuations. And all the short term movement means seasonal variations and another is the cyclical variations. These are the component of time series. So mostly there are the four main category of the components in the time series analysis. So I have already discussed long term movement, trend, seasonal short term movement, cyclical short term movement, and random and irregular fluctuations. So long-term movement or a trend, overall the movement of the time series value to a increase or decrease during a prolonged time interval. It is the common to observe a trend changing directions throughout the course of your time series data set, and they may increase or decrease or remain stable at a different moments. So overall you will see the one primary trend: population counts, agriculture productions and items manufacturers are just some example of when a trend may come into play. But there are two different types of the short term movement. One is the seasonal variations. So seasonal variations are a periodic temporal fluctuations that shows that the same variations and usually they recur over a period of the less than a year. So seasonality is always a fixed and known period like a summer and winter. Coca-Cola आज means selling has been increased in the summer and it has been a decrease as a winter. So most of the time these variations will be present in a time series. So if the data is recorded hourly, daily, weekly, quarterly and monthly, so different social conventions such as the holidays and festivals, also weather seasons, the climate conditions play an important role in a seasonal variations. Like for example, for the sales of, just I have already discussed, Coca-Cola, umbrella and raincoats in the rainy seasons, air conditioned season in a summer seasons. So these are the seasonal variations. Another is cyclic variations, means one of the other sides are the recurrent pattern that exist when the data exists the ridges and falls that are not of a fixed period, one complete period in a cycle. But a cycle will not have a specific predetermined length of time. So even if the durations of these important fluctuations is usually a long than a year. So a classic example of these cyclical variations is a business cycle, which is the downward and upward movement of gross domestic product around its long term growth trend, and it usually can the last several years, but the durations of the current business cycle is unknown in advance. So cyclical variations and seasonal variations are the part of the same short term movement in the time series forecasting, but they present a different and data scientists need to identify and leverage in order to build accurate forecasting model. So we can easily understand if you can see a straight line and another point is the up and down. So sometime you can say the period of prosperity and sometime you can say the period of recessions. So if you draw a trend line like a straight line and go the down, so you can see the period of depressions, and if you go the up, period of prosperity. So cyclic period means like a zigzag. Random and irregular fluctuation are the last element to cause a variations in our time series data, and these fluctuations are uncontrolled and unpredictable and erratic, such as earthquake. This is the randomly wars, flood like Ukraine and Russia war, flood. Just it had happened in the some European and Asian American country, cyclone types of something. So any other natural disasters. So let's see, the data scientists refer to the first three components like a long-term movement, seasonal short-term movement and cyclical short-term movement. So as the signals in the time series data, because they actually are deterministic indicator that can be derived from the data itself. So one of the other hand, the last component like a random and irregular fluctuations are arbitrary variables of the values in your data, and you cannot really predict because each data point of these random fluctuations is independent of the other signals above, such as the long term and short term movement. And for this reason, data scientists refer to it as a noise because it is triggered by the latent variable difficult to observe. So random noises means sometimes it go down and go up suddenly. Okay, actual demand means just look like a making a pattern. So data scientists need to carefully identify to what extent that each component is present in the time series data. We are able to build an accurate machine learning forecasting situation. So whenever we see the pattern and to recognize and measure these four components, and it is recommended to the first perform and decomposition process to remove the components effect from the data. So after these components are identified and measured and eventually utilized to build the additional feature to improve the forecast accuracy. So data scientists can leverage different methods to recompose and back the components on forecast results. So now the understanding these four time series components, so how to identify and remove them, they represent a strategic like a first step for building any time series forecasting solutions, because they can help with another important concept in a time series, may help increase and predictive the power of your machine learning algorithms like a stationarity. Stationarity means the statistical parameters of time series do not change over a time. So the basic properties of the time series data distributions like mean, variance remain constant over time. So therefore a stationarity means stationarity time series process are easier to analyze and model because the basic assumptions is that their properties are not dependent on time and will be the same in the future as they have been in the previous historical period of time. So we try to understand. So first we try to understand time series stationary. So there are two important forms of the stationary. One is the strong stationary, another is weak stationary. So a time series is defined as having a strong stationary when all its statistical parameters do not change over time. So a time series is defined as having a strong stationary when all its statistical parameters do not change over time. Like a statistical parameter means like a mean, median, mode, variance. Okay. And the time series is defined as having the weak stationary means when its mean and auto-covariance functions do not change over a time. So only mean and output values. So the time series that changes in the value of their data, such as a trend or seasonality, are clearly not stationary, and the consequence they are the more difficult to predict and model. So for accurate and consistent forecasted result to be received, and the non-stationary data needs to be transferred into stationary data. Another important reason for trying to render a time series stationary is to be able to obtain a meaningful sample statistics such as mean, variance, and correlations uh, with the other variance that can be used to get a more insight and a better understand your data, and can be included as an additional feature in your time series datasets. Next, just there are some cases where the unknown non-linear relationship cannot be determined by a classical methods like auto-regressions, moving average, auto-regressive integrated moving average methods. So this informations can be very helpful when building a machine learning model, and when it can be used in the feature engineering and feature selection process. In a reality, many economic time series are far from stationarity when the visualized in there, like you can use the plotly. So in there means when visualized in their original units of measurements, and even after a seasonal adjustment they will typically still exhibit trend cycles and other non-stationarity characteristics. So time series forecasting involve developing and using a predictive models on a data where are the ordered relationship between observations before data scientists and get started with the building their forecasting solutions. So it is a highly recommended and to define so many forecasting aspects. So I hope it will be clear. So you try to understand the some concept here, and one of them is like a some like the input and output of your forecasting model. So the data scientists who are about the build of forecasting solutions, so it is critical to think about the data and they have available to make the forecast and what they want the forecast about the future. So input are historical time series data provided and to fit the model in order and to make a forecast about future value. Output are the predictions result for the future time aspects. So let's see the example. So last 7 day stock price. So we can collect from the Yahoo Finance and other financial sector like a Quandal, and just I want to find the otherwise you can say similarly last 7 day of energy consumptions data collect by some website, and now by the sensor of the electrical grid is considered into the data, and while the predicted value of the energy consumptions to forecast for the next day and define the output. Similarly the stock price can forecast the next day and next month, next year. Now the granularity level of your forecasting model. So granularity in a time series forecasting represent the lowest detail level of value captured for each time instance. So it is related to the frequency at which time series value are collected usually. So if we talk like a IoT scenarios, the data scientists need to handle a time series data that has been collected by sensor. So Arduino, just I am using Arduino and I am collecting a data like a rain forecasting and weather forecasting and to others also. So like this, so IoT is a typically defined as a group of the device and that are connected to a internet, all collecting, sharing and storing a data. Example of the IoT device are temperature sensors in the air conditioned units and pressure sensors installed on a remote while pump. Sometimes aggregating the your time series data can represent as the important steps in the building and optimizing your time series model. So time aggregations is the combinations of all data points for a single resources over a specified period, and which aggregations the data point collected during each granularity period are aggregated into the single statistical value such as average sum of the all collected data point. Next, horizon of your forecasting model. So horizon of your forecasting model is a length of the time into the future for which forecasts are to be prepared. So these generally are vary from a short-term forecasting horizon, short-term, long-term horizons. Short-term forecasting usually use the short-term objectives such as the material requirement planning, schedules, budgeting. Other hand, the long-term forecasting usually to predict the long-term objective like more than 5 year bonds, others, and sales advertising. Next is the endogenous and exogenous features of your forecasting model. So endogenous and exogenous are the economic term to describe internal and external factors respectively affecting a business productions efficiency, growth and profitability. And endogenous features are an input variable that have a value that are determined by other variables in the system, and the output variables depends on them. So for example, if the data scientists need to build a forecasting model to predict a weekly gas price, they can consider the including the major travel holiday as a enormous variables, and the price may go up because the cyclical demand is up. Similarly, the gold price also. And the other hand, the exogenous features are a input variable that are not influenced by the other variable in a systems and on which the output variables depend. So exogenous variables present the some common characteristics such as they are the fixed when they enter the model and they are taken as a given in the model. Other, they influence endogenous variable in the model. They are not determined by the model. They are not explained by the model. So let's see the some example like a predictive weekly gas price, and while the holiday travel schedules increases the demand based on the cyclical trend, and overall the cost of the gasoline could be affected by while reserve price and socio political conflicts and other disasters such as the wild tanker accident, like other things. So next is the structure and unstructured features of your forecasting model. So structured data means comprises clearly define the data types, which pattern makes them easily searchable, while unstructured data comprise data that is usually not as easy searchable, including formats like audios, videos, social media postings. So structured data usually resides in a relation database whose field store length delineated data such as the phone numbers, social security numbers, zip codes, and similarly unstructured data has internal structures but not structures via the predefined data models or schema. So it may be the textual and non-textual, the human or machine generated. So typically human generated unstructured data include spreadsheets, presentations, email, and log. So typical machine generated unstructured data include a satellite image imaginary and weather data, landform, military movements. So in the time series context, unstructured data does not present a systematic time dependent pattern, and while the structured data it shows the systematic time dependent patterns such as a trend and seasonality. Next thing, we have to understand the univariate and the multivariate nature of your forecasting model. So a univariate data is characterized by a single variables. It does not deal with a causes or relationship. Its relationship. Now, it descriptive property it can be identified in the sum like estimates such as the central tendency like a mean, mode, median. Dispersion like a range, variance, maximum, minimum, quartile, and standard deviations. So and the frequency distributions. But the univariate data analysis is known as its the limitations in the determinations of a relationship between two or more variables, correlations, comparisons, causes and explanations, and cognitive between the variables. So generally it doesn't supply a further information on the dependent and independent variable, and as such it is insufficient in any analysis involving more than one variable. So to obtain the result and from the such a multiple independent problems, data scientists usually they use the multivariate data analysis. Multivariate approach means will not only help us consider the several characteristics in the model but will also bring to a light the effect of the external variable. So time series forecasting can either be a univariate or a multivariate. So the term of the univariate time series it refers to a one-off consistent or a single observations record sequentially over an equal time increment. Unlike the other area like a statistics and univariate time series model containing the lag value of itself as an independent variable. So the lag variable can play the role of independent variable as in a multiple regressions. So multiple time series model is an extension of the univariate case and involves two or more input variables. It does not limit itself to its past information but also incorporates the past of the other variables. So multivariate process arises when several related time series are observed simultaneously over a time instead of a single series being observed in a univariate case. Like Univariate time series are like ARIMA models, ARIMA, autoregressive integrated moving average models that can just that will be discussed later. But look here, just if the number of variables may differ between the input and the output for like a data may not be summarized symmetrical. So you may have a multiple variables as an input to the model and only be interested in predicting one of the variables as an output. So in this case there is an assumption in the model that the multiple input variable and are required in predicting the single output variable. Single step and multiple step structures of your forecasting model. So time series forecasting describe the predicting the observe the next time steps. So this called the one step forecasting and only the one time steps to be predicted. In contrast, on the one step forecasting are the multiple steps and multiple step time series forecasting problem. So where the goal is to predict and the sequence of a variable in a time series. So many time series problem involve the task for predicting a sequence of values using only the values observed in the past. Exactly, we have taken the past prices and now I am going to predict the future. So like a tasks including the predicting the time series for a crop yields, stock price, traffic volumes, electrical our consumptions. So there are at least four commonly used strategy for making the multi-step forecasts. If the direct multi-step forecast means the direct methods require the creating the separate model for the each forecast time stamps, and for example like a case of the predicting energy consumptions for the next 2 hours, and we would need to develop the model for forecasting energy consumptions for the first hour and the step and separate the models for forecasting energy consumptions on second hour. Same recursive multi-step forecast, multi-steps ahead of forecast can be handle a recursive where a single time series model is created for forecast the next time stamps, and like just we are going to following a forecast are then computed using the previous forecasts. So case of forecasting energy consumptions for the next 2 hours. So we would need to develop the one step forecasting model, and this model would then be used to predict the next hour energy consumptions, and then these predictions would be used as an input in the in order to predict the energy consumptions in the second hour. Direct recursive hybrid multi-steps forecasting. So the direct and recursive strategy can be combined and to offer the benefit of the both methods, like a distinct models can be built for the each future time stamps. However, the each model may leverage the forecast made by a models at a period time steps as input value. So in this case, in the case of the predicting energy consumptions for the next 2 hours, two models can be built, and the output from the first model is used as an input for the second model. Say multiple output forecast I discuss. So multiple output strategy required developing the one model that the capable of predicting the entire forecasting sequence. So for example, in the case of predicting energy consumptions for the next 2 hours, we would develop one model and apply to predict the next 2 hours in the one single consumptions. Next is the one more thing, just to try to understand contiguous and non-contiguous time series value in your forecasting model. So time series that present is the consistent temporal intervals, like every 5 minutes, every 2 hours, every quarter, between the most of the time we are using in the stock price forecasting and energy consumptions also. So one of the other hand, the time series are not uniform over time and may be defined as a non conjugious vary often the reason behind the non contiguous time series and maybe a missing and sometime you can the corrupt values. So before going to this method data imputations, so it is important to understand the reason of the data goes missing. So there is a most keep in your mind only the three most important common reasons is the missing at random, means missing a random means that are the propensity for the data point to be missing is not related to the missing data, but it is related to the sum of observed data. Missing completely at random, so the fact that the certain value of missing has nothing to be with its hypothetical value and with a value of other values. Missing not at a random. So two possible reasons are that the missing value depends on the hypothetical value of the missing value dependent and some other variables. So first two cases, like a missing at a random and missing completely at a random, is the safe to the remove the data with the missing value dependent upon their occurrences, while in the third case is removing observations with the missing value can produce a bias in the model, and there are a different solution for a data imputation dependent on the different kinds of problem. So you are trying to solve, and it is difficult to provide a general solution. So moreover, since just is the look here, we have already something if I have identified the some of the most common used method and a list some structure guided, like the handling the missing data in the time series. So first the missing data deletations in the time series, another is the missing data imputations in the time series. So deletations means it can be like a list wise deletations, pair wise deletations and column deletations, and another is the missing data imputations is in the time series data without trend and with seasonality, and data with trend and without seasonality, data with a trend and with seasonality. So like data without trend and without seasonality means mean, median, mode, random sample implementations. Another is the data with a trend and without seasonality means linear interpolations, and data with a trend and with a seasonality, so seasonal adjustment and interpolations. So just these are the way to handling the missing data. This is the way to the handling a missing data. So the completely this is the because the assumptions is the missing completely at random method are typically rare suppose. So I hope uh, linear interpretation, seasonal adjustments of the linear. So some specific method like a time series specific methods, mean, median and mode. So before that, the next sections of the after that, uh, how to the shape the time series as a supervised learning problem and consequence and get to the large portfolio in the linear and non-linear machine learning. So I have already made some what is the difference between the supervised and unsupervised learning, but I try to discuss in a detail and in the next video, and then we try to discuss the some Python's time series forecasting, some specific libraries it contains like scpy, numpy and matplot, pandas, stats models, scikit learn. Okay, so these are the important keras is the important to understand, and you can apply also the Visual Studio codes, Visual Studio Code Python extensions, Python 3 and other. Thank you for, I think it will be helpful for everyone.